Hi, welcome back to Moose and Chemistry. Today we're going to do VSEPR Models Lesson 4. The first compound that we're going to work on is silicon tetrachloride, which is Si. Now, silicon is in group 14, so it has 4 valence electrons. And chlorine is in group 17, so it has 7 valence electrons. So now we're going to figure out what our total number of valence electrons for the structure is going to be. So we have Si, we have 1 times 4 electrons, and Cl is 4 times 7 electrons. This gives me a total of 28 electrons for chlorine, 4 electrons for silicon, which is a total of 32 electrons. All right, so this works pretty well. Now what we're going to do is we use silicon as our core, and we're going to do the wraparounds with the chlorine. So we're going to put chlorines evenly spaced around the silicon. So we go 2, 4, 6, 8. Now we need to complete our other electrons. 2, 3. So we have 8 times 4 is 32 electrons. But now we have to check to make sure this is the best possible structure. To do that, we have to use formal charge. So we're going to do the formal charge of silicon first. So now, remember that formal charge is equal to valence electrons minus non-bonding electrons minus bonding electron pairs. Okay, so silicon comes in with 4 valence electrons. They're all bonded, and we have 4 bonding pairs, so that gives us a total charge of 0. And that looks really, really good. Now let's check one of the chlorine atoms. Now, when we do the formal charge of chlorine, remember that we don't have to do all 4 of them because they all look the same. So chlorine comes in with 7 valence electrons. It has 6 non-bonding electrons and 1 bonding pair. So that gives us a value of 0 also. So that's good. So we know that this is the best possible structure. Now, let's do a couple other things. First of all, let's determine what kind of structure we have here. So we use the core as A, and each chlorine gets an X. So this tells me that this is an AX4, which is a tetrahedral structure, and it has bond angles of 109.5 degrees. Now, we can also look at the hybridized orbitals. Remember that every line is equal to a sigma bond, and unshared pair electrons also count. So let's count the number of hybridized orbitals. We have 1, 2, 3, 4 for the silicon. So we have 4 things that we have to fill in, so that would give us sp3. So our silicon is equal to sp3. Now let's check out the chlorine just to make sure. So our chlorine has 1, 2, 3, 4 also. So each chlorine is an sp3 hybrid orbital. All right, so we're going to clear these, and we're going to start on the next molecule that we want to do. So let's clear all the drawings, and they're clear. And now we're going to do another one. This one is going to be sulfur dichloride, SCl2. Now sulfur is in group 16 and has 6 valence electrons. Chlorine is in group 17 and it carries 7 valence electrons. So let's go ahead and add all this up. Sulfur is 1 times 6 electrons, and chlorine is 2 times 7 electrons. So let's total this up. We get 14 valence electrons for the chlorine, 6 valence electrons for the sulfur. Okay, that looks pretty good. So now we're going to make that 20 valence electrons. So whatever structure we draw has to have 20 valence electrons. So we're going to put S in the center because it's the least electronegative. Put each chlorine on either side. First, we're going to complete the bonds between the sulfur and the chlorine. There's 2, there's 4. Now we have to fill in the chlorine. Let's give you 6, 8, 10, 12, 14, 16, 18, and 20. So now we need to redraw the structure because we have these two free unshared pair of electrons, and they're pushing down on our bond angles, which are here and here. So clear that out. And so now our new drawing is going to look a little bit better like this. So we're going to get S, and we're going to put a Cl here, S, and a Cl here, dot, 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 dot. Put our dots around our chlorine. Now, when we look at this, let's check to see if this structure is perfect. So we're going to do formal charge of sulfur. Again, remember, it's valence electrons minus non-bonding electrons minus bonding electron pairs. So sulfur comes in with 6 valence electrons. Our non-bonding electrons, I count 2 there and 2 there. That gives us 4 electrons. And our bonding pairs are right here, 1 and 2. So 6 minus 4 minus 2 is 0. So that's looking really good. Let's check out our formal charge for one of the chlorines. We don't have to do them both because they both look the same. So chlorine comes in with 7 valence electrons, sorry. And there's one in there, of course. Minus 6 non-bonding electrons, because we can see those right there, right here, and right here. Minus 1 bonding pair there, so that gives us 0. So that looks really, really good. So this structure is very, very good. Now, let's look at this structure here. We have A, X, X. This is going to be E1. This is going to be E2. So we would call this AX2E2. And in our VSEPR models, that is a bent shape structure. And that also has 109.5 degrees angles right here, 109.5 degrees. Now, let's look at the hybridized orbitals for S. Now remember that sigma bonds and unshared pair electrons, this is your sigma bonds, and unshared pair electrons count. So S has 2 unshared pair and has 2 sigma bonds. So that's 1, 2, 3, 4. That would give us sp3 for our hybridized for sulfur. Sulfur has a hybridized orbital, sp3. Chlorine, again, also has 1 sigma bond and 3 unshared pairs. So that would also give us sp3 orbitals, for hybridized orbitals for that. So our correct structure, again, looks like this. S, then chlorine, and that's our correct structure. Okay, so let's clear all our drawings. We'll clear the drawings here. We're going to do one more. And now what we're going to look at is sulfur hexafluoride, which is SF6. Now, again, S contains 6 electrons because it's in group 16, and fluorine contains 7 valence electrons because it's in group 17. So we have 1s times 6 electrons, and we have 6f's times 7 electrons. This gives me 42 electrons for fluorine, 6 electrons for sulfur, which is a total of 48 valence electrons. So let's go ahead and draw this. So we're going to put our S in the center, and we're going to stagger these F's. So we got 2, 4, 6, 8, 10, 12. And then we're going to put our wraparounds on the fluorines. And we count that, that's 6 times 8, which gives me 48 valence electrons. So let's see if this is the best possible structure. Now remember that we have to use formal charge. So we go the formal charge of S is equal to, remember, the valence electrons minus the non-bonding electrons minus the bonding electron pairs. So sulfur comes in with 6 valence electrons, 0 non-bonding electrons, and 6 bonding pairs, which gives us a total of 0. Let's look at each of the fluorines, but we only have to do one of them because they're all the same. Fluorine came in with 7 valence electrons, 6 non-bonding electrons, and 1 bonding pair. So both these look good. So now, let's do the VSEPR model structure of this. So now what we're going to do is we're going to check for the VSEPR model structure. All right, our S is going to be our center, and we put an A there, and we put X's around these. So it looks like it's going to be AX6. Now an AX6 model is called a octahedral structure. And now let's check our hybridizations for this. So if we look at our S, we actually remember that hybridization deals with sigma bonds and unshared electron pairs. So if we look at the S, we have 6 sigma bonds. So S would be 1, P maxes out at 3, so that would be 1 and 3 make 4, so we need D2. So our hybridized orbital would be sp3d2. Let's check out the hybridized orbital for F. We have 3 unshared pair electrons, which are located right here, right here, right here. And that would give us, and then 1 sigma bond, that would give us 4, so that would be sp3. Now the bond angles on an octahedral are going to be 90 degrees. So each one has a 90-degree angle. And that's it for this VSEPR model lesson at Moose in Chemistry. Have an awesome day.